Huzaifa is our working group speaker in safety, and I think also a strong person also inside of the adaptive community. We're great to have you here. Huzaifa, word is yours. Thanks.
Thank you very much, Renat. So, as Renat has already mentioned, my name is Josefa Sadat, and I'm the speaker for Working Group Safety. And today, the idea is to walk you through the three concepts that we've released in 21-11. So the agenda would look something like this, where I start off with talking about the first concept, which is system health monitoring, after which I would go on to mode-dependent configuration, and at the end, I would say a few words about end-to-end for fields, what Renat just briefly mentioned. So starting off with system health monitoring, I think it makes a bit sense that we start off with the picture on the right-hand side just to give an idea of what the whole idea is with respect to this concept. So we see there we've got three platforms. One is an adaptive AutoSAR, one is the classic AutoSAR, and one is a non-AutoSAR platform. And the classic platform actually hosts a so-called system health monitoring manager, whereas the other two platforms host the clients. The whole idea was to have something that could give you an indication of the health from a safety perspective of different platforms within a vehicle. And this meant that one requirement that we thought was very important was getting a bit out of the scope of AutoSAR and thinking about the overall vehicle, which meant that our concept had to be platform agnostic and should be able to coordinate health status and errors system-wide. So the idea is that the system health monitoring clients communicate platform health, so they know about their own platform's health and they communicate this, whereas the system health monitoring master determines the health indicators. And this health indicators could also be an OEM-specific algorithm of how they would like to implement this. And these health indicators could be of different granularity. It could be a subsystem level, it could be a feature level, a domain level, or the vehicle level in itself. One use case of that would be where the system figures out, okay, a specific platform is low on health, which would be a calculation made from the health indicator, and the whole system coordinates together with the system health monitoring master client and the own features such as PHM and adaptive platform and watchdog manager in classic platform together with the state machines that this specific platform needs to go into a degradation state, for example. So this concept was divided into two parts, the second part being the standardization of application interfaces. So that's probably what we did in part two. So if I'm to tell about the user benefit of this concept, I would say it is a platform independent mechanism to monitor the health of machines across the vehicle. Moving on to our next concept, that is mode-dependent configuration. So before I start explaining the mode-dependent configuration, it makes sense to just talk about what platform health management in adaptive AutoSAR is responsible for. It is a safety feature which is responsible for supervising safety-related applications. And it provides three kinds of supervisions, namely the alive supervision, the deadline, and the logical supervision. So this means that it checks on the frequency, the deadlines, and sequence of software execution. And all these three characteristics can change based on the mode that we are running in. At this point in time, I would probably refer to the picture that we see on the right-hand side. For example, in a normal state, if there has to be a process, or let me call it just a piece of software that needs to execute 5 times in 10 milliseconds, my expectation now would change if my system goes into a power saving mode. Now, I wouldn't expect this specific software to execute 5 times in 10 milliseconds, but maybe 2 times in 10 milliseconds. And this is made possible now with mode-dependent configuration. This was also divided into 2 parts. The second part was basically to also make it possible to disable a supervision in a specific mode. So we may want a safety application to be supervised in a certain mode. Very high abstraction level would be, for example, a radar or lidar sensor when we're either on autonomous driving or ADAS systems, like on adaptive cruise control or something. But when we're manually driving, maybe that's not that important to be supervised. So this part also provides this capability of not supervising something in a different mode. So if I'm to tell about the user benefit for this specific concept, I would say that it makes the adapting of monitoring based on different function group states possible. Moving on to the last concept from safety side that was delivered this release is the end-to-end for fields, and this comes from another subgroup. So we've got one subgroup as platform health management, which was responsible for the first 2 concepts, but this is then the responsibility of our third or the other working group, which is end-to-end. And some of you might already know in some IP, we've got the mechanisms of methods, events, and fields. And fields is, something what we can relate to as a publisher or subscriber pattern that you see on the right-hand side, where you have a publisher and there is a provider of a field value which sets a specific value, but on the other hand, from this publisher, a lot of clients have subscribed to this specific value that they are interested in. So if a setter sets a value, the publisher sends a response that this had been set, and on the other hand, updates the subscribers as well that the new value is now available. So this mechanism is, already exists in some IP. The only issue was that it was not possible to protect it with respect to the end-to-end from the AutoSAR. And this concept basically combined the scenarios of end-to-end for methods as well as end-to-end for events. So it is, let's say, not a very exhaustive concept. It was known as lightweight concept, and it was targeting end-to-end for fields. So now with this concept, it is also possible to protect our data with respect to fields. What happens, or the advantage that we get here, is that either the lost, repeated, or tempered messages can be checked, verified at the receiver's end. So if I'm to put a user benefit here, so it's basically, now that we had in our previous releases and protection for methods and events, the only thing that was missing was protection for the fields. So now this provides safer communication with respect to fields as well. And with that, that concludes my part of the presentation. So thank you very much. And I guess then Richard would be next.